right, guys. So today we're going to be starting something called interval notation. I don't think anyone will have seen this before. It's a different way to write inequalities. So we're going to start off, we're going to draw a number line. So on this first example, it says to draw a number line, then write the following inequalities in interval notation. When a value is not included, we're going to be using parentheses on that number. If a value is included in the set of solutions, then we're going to be using a bracket. So there's a parenthesis, a bracket is square, like that. A value of positive or negative infinity is always going to use parentheses. All right, so looking at example 1, we're going to graph this on a number line. So I'm just going to put the number 4. Do you guys remember, do we use an open or a closed dot if it's not included? Open, good job. So I'm going to circle the 4 with an open dot. I want the x's that are greater than 4, so that's going to go down here to the right. So all of these numbers down here to the right of 4, those are going to be solutions. Here's the way we write this in interval notation. We always read from left to right, just like we do a book. The first number we come to is 4. And I use a parenthesis because it's not included. And then I say comma, and this is going all the way down to infinity. And we never use a bracket around infinity because we can't be equal to infinity. There's no such thing. So that's how we write that in interval notation. These mean the same thing. This is kind of thought of as like the less sophisticated way of writing it. Interval notation is what you use when you get into pre-calc, calculus, so we're going to start it now. Okay? All right, looking at example 2, we're going to put our number line, going to put our number 2, open or close dot. Close dot. Which way do I shade, right or left? Left. So down here to the left, this is called negative infinity because these numbers keep getting smaller and smaller and smaller and smaller forever. So the way that I have to write this, I have to start with the smaller value. Is 2 smaller or negative infinity smaller? Negative infinity. So this would be called negative infinity, comma 2. And I'd have to use a bracket around the 2 to show that that is included. Any questions? All right, example 3. This is saying that x has to be less than 5 and x has to be greater than or equal to negative 2. So I'm going to make my number line. Here's my negative 2. Here's my 5. I have to be greater than or equal to negative 2. And I have to be less than 5. Notice how this one is shaded and this one is open. Now, where am I going to shade? Am I going to shade the outer part or the inner part? Inner part. That's what we call a conjunction and an and statement. And that's because we have to be less than 5 and greater than negative 2. That's how we write it as an inequality. There's our number line. Here's interval notation. Left, the first number I come to is negative 2, comma, 5, parentheses. That means all the numbers between negative 2 and 5, negative 2 is included, 5 is not. Okay? Does that make sense? All right, let's look at example 4. Create your own number line. This is how your number line looks. This is called a disjunction. It's called an OR problem. So we're saying that the only way this is going to work is if X is down here or X is down there. It can't meet both requirements. It can be here or here. Anybody think they know what I would call this, where this starts? What's that called? What do we call it up here? Right, so this is going from negative infinity, and where do we stop? -5, parenthesis or bracket. Good. Now, this is a little different. I now put this union symbol. What that means is or. A union symbol means or. Okay. Now we pick back up with what number? Yep, thank you. I didn't catch the negative. And that's the way that would look in interval notation. What questions do you have so far? All right, let's keep going. Number 5. Here we have another disjunction. We see the or, but all this is two problems that we have to solve. We have to do the problem on the left first. So I'm going to have to add 1. So I have to solve the problem on the left. And then I also have to do this problem on the right. I now have to divide by 2. Let me get this. And now I want you guys to try to write the number line and also write it out in interval notation, that solution. Right. Carrie, do you know how to write it in interval notation? Okay. Yep. Nice job. That's perfect. Some of you get that right? Excellent. So we use the bracket. Why, you guys? Right, to show it's included. Otherwise, we're just getting closer to it, but not including it. Okay, going to go on to example 6. This one's a lot more challenging. This is a conjunction. So we actually have 3 problems here, though. This is going to have to be less than 0, but this is also going to have to be greater than or equal to -10. I have to get rid of this -6 first. So how do I get rid of subtracting 6? Add 6, and I have to do it to every part. I add 6 here, here, and here. And so now I'm going to have -4 is less than or equal to -2x is less than 6. What do we do now? I need to get x by. Good. Divide by -2. Does anyone remember what happens to inequalities when we divide by a negative? What do we have to do? Yeah, Harper's right. We have to switch the inequalities around. Okay, so a -4 divided by -2 is +2. I divided by a negative, so I have to switch this around. This is now an x. I divided by a negative. I have to switch that around. So see what we did? This is 2. I had to switch this because I divided by a negative. I had to switch this one because that negative. And now we run across another issue. Why do you think I don't like the way this is written? Yeah, we want this to go from smallest to greatest. So if I want to put the negative here and the 2 here and the x here, yeah, I have to keep it equivalent. So I have to flip the signs around to keep it equivalent. This is now the same thing. It's not because I divided by a negative. It's because I am switching the negative 3 first. X still has to be greater than negative 3. X still has to be less than or equal to 2. And this is saying the same thing. Can you guys write this directly in interval notation now? All right, do that. And this is what you should get. Did you get everything right there? Okay. We're going to switch gears now. We're going to go to absolute value. All right, it says absolute value examples, and these are equations. These are not inequalities. So it's not like we're trying to write this in interval notation. This is saying the absolute value of what number or numbers would equal 3. What do you guys think? Negative 3 and 3, right? The reason why is because this really means the distance from 0 has to be 3. Well, negative 3 works and 3 works. We have 2 solutions there. And you typically want to go from smallest to greatest. That's the way we want to get in the habit of doing that. What about this one? The absolute value of something has to equal negative 4. What do you think? Okay, I agree. It's not going to happen, is it? There's no number that's going to work. We really don't want to say undefined, though. It's better to say no solution, or you could say the empty set. That just means there's nothing that's going to work. Impossible. All right. Now we're going to take that a step further, and we're going to look at equations with absolute value. Okay, so example 8. This is saying the absolute value of this has to be 11. Well, what we just learned is that this is actually able to equal negative 11, or that can equal positive 11. That's our first step. Whatever's inside of here is allowed to be negative 11 because the absolute value of negative 11 is positive 11, or whatever's inside of here has to be positive 11. You have 2 problems to solve. See if you can solve them on your own. That's a little squiggly bracket there. So what we're saying then is x can be negative 6 or 5. The other way you can write this is in set notation, negative 6, 5, but I usually just write it like that, but both the same. Okay, example 9. Before we can even start this problem, we have to do something because I don't have just absolute value here like I need. So what am I going to have to do before I set it up? Yeah, you have to subtract 1 first. And once you've done that, now you can set it up and solve. So go ahead and do that on your own. Get it? -9 or 3? Great. Okay, last part here. We're going to be looking at equations and finding the domain and range. So part A, f of x just means y. This is really saying y equals 3x minus 4. Do you guys know what that looks like? Y equals 3x minus 4, what kind of shape it is? It's just a line, isn't it? I'm going to show you the graphing calculator for the first time. May not use this much. I'm going to go to y equals 3. Here's the x button, x minus 4. I'm going to graph it, and it shows me what it looks like. Okay, is that what you were thinking? Good. So I'm going to do a quick sketch of that. So the y-intercept is -4, the slope is 3. And now to find the domain, that's the x's we can use. Well, this keeps going to the left and to the right. So the domain of this is -infinity to infinity. In Algebra 1, you probably put all real numbers, but we're going to be using set notation, or I'm sorry, interval notation now. So you're going to write it like this. The range, that's the y values we can use. Well, this goes down forever and up forever. So what do you think it is? Yeah, same thing, right? All right, do you guys know what absolute value functions look like? What kind of shapes they make? Good job, they do make V's. My other class was saying a U, but absolute value is a V. I'm going to do it on the calculator to show you. And this will be weird because I know you haven't done it, but we go to y equals. I'm going to clear this. I have to go under math on this to get to absolute value. And then I have to go over to number and ABS. That's how I get to absolute value. And then I'm going to have x minus 2 inside of here and then plus 1. I'm going to graph it. So where do you think this point is right here? 2, 1, isn't it? Okay, so I'm going to do a little sketch of that. That's the graph. 2, 1 is the vertex of that graph, rather. That's the way that's going to look. I want you guys to write the domain and range. Anybody know the range on that one? We have to, for the range, we have to look at our lowest y value we use. What's the y value right there? 1. So it's going to go from 1 to infinity. Anybody get that? Do you guys understand now why it would be that? We look at our lowest y value. All right, and then our last one here, y equals -x squared plus 3. Do you guys know what that looks like? It's a u, right? It's going to be shifted up 3, and then which way is it going to open? Down, okay? And the proper name for it's a parabola. Okay, try to write the domain and range on your own. Hayden, do you think you know the range?
Um, -infinity.
Good job. Did you use a parenthesis or a bracket on the 3? Why? Very nice. All right, guys. Think you've got it? All right. We're short on time, so these were just going to be examples if we had time, but we don't, so we're going to stop there.